Hello everyone, welcome back to another interesting question. This is a simple question. If you use a trick, one simple idea we have, one small trick that we are going to use. Otherwise, it looks very complicated. This is a question from Pathfinder, collisions related problem. Let's have a look at it. This is question number 21. Four identical small blocks, identical they said, meaning they're all equal masses, marked 1, 2, 3, and 4 with respect with separations A, B, C as shown in the figure. So between 1 and 2 separation A, 2, 3 B, and then 3 to 4 separation is C. So they are approaching the wall with the same speed. That means their separation will remain constant until it collides with the wall. Relative velocity between any two bodies is 0. If all the collisions are perfectly elastic, so E equal to 1, with what velocities and separations will the blocks move after all the possible collisions? Yeah, so this question, if you want to solve it like each collision analyzing, it's going to be pretty lengthy. So what will happen? Just let us understand that one will collide with the wall first, and then it will return back with the same speed, while two would be approaching. So it will collide with two. Then again they will exchange their velocities. Velocity of 2 will go to 1 and velocity of 1 will go to 2, meaning 2 will go right side and 1 will go back, and this 2 will collide with 3, and then again velocities will be exchanged between 2 and 3. So velocity of 3 will go to 2, 2 will go to 1, like that, and 3 will collide with 4, and 4 velocity will get reversed like that. And if you look at A, it goes back to the wall now. Again it will have a collision, it will return back. So it's going to be very complicated that way if you observe. Instead of that, right, there is some simple idea. Let's try to understand it. First, let us take one case. Suppose you have a block P and it is approaching the wall U there, and assume that the collision is perfectly elastic. Then what happens? This block will collide with the wall and it will return with the same speed U in opposite direction. E equal to 1 we are considering. So the same thing, the way that we can visualize as, imagine that this wall behaves like a mirror and you have its image on the other side, and you can imagine that the block goes into the wall and its image will come out simultaneously. As the block goes into the wall, image will come out with the same speed in opposite direction. So mirror image idea. So that way you can imagine visualizing, like actually what is happening, this block collides with the wall and returns back with the same speed, but the same thing can be visualized as if this block goes into the wall and the reflection part will come out. So the same idea we'll use when we talk about waves also. When the wave is falling on a wall, a reflected wave, when we want to analyze this particular idea, we'll use there also. So this is one strategy. Now let us say there are two blocks here, A and B. They are approaching each other with the same speed and equal mass and elastic collision. Then what would happen? They will exchange their velocities. They go in opposite direction like that. So the same thing that you can visualize, like A is going through B and B is going through A, as if they are going through each other and then they're going like this. If you don't know the symbols there, whether it is A or B, you don't understand which block is what. So you can imagine as if A is going through B to the other side and B is going through A to the other side. It's the same idea we'll have it. When the waves are going in opposite direction, they just pass through each other. Similarly, you can imagine that these two blocks are just passing through each other. In reality, they are not passing, they are colliding and rebounding. But finally, a situation would look like that. That way you can imagine as if they are passing through each other. Now let us extend this idea. Now you have a block A and block B. Both of them are going in the same direction towards a wall. Now you will have collision with the wall and also collision between them. Now what you can imagine is these two blocks are there, A and B, and wall behaves like a mirror, and then you have their images going in this direction. As the block A approaches, A dash also will approach, they pass through each other. As the block B approaches, B comes and then they pass through each other. So totally A and B can be assumed to be going in this direction into the wall, and their images will come out as the blocks like that. So it's like a train going and then turning back like that, you can imagine. Otherwise, incident pulses are going in and the reflected pulses are coming out. That way you can imagine. So the same idea will extend it to whatever the question they had given. Now let's look at the diagram here. 1, 2, 3, 4 are given like this with separation A, B, C. And if you take this wall as a mirror, you will have their mirror images on the other side. So this 1, 2, 3, 4 will go through the wall, and then this 1, 2, 3, 4 will come out of the wall like that, you can imagine. So eventually this 1 will come here, and then 2 comes out, and then 3 comes out, and then 4 comes out. The separation will be A, B, C like this in reverse order. But of course, numbers you need to be careful, because what comes out is actually 4. It looks like that, but numbering wise will be, this is going to be the fourth one, 3, 2, 1. The numbering would be same, but to understand the motion of it, this idea would be very much useful. I hope you understand. It's a very simple, beautiful idea. The same idea we are going to use it in the case of waves also. I hope you enjoyed that. So with that, I'll conclude this one. If you have any doubt, please let me know. I'll be very happy to discuss with it. Until next time, goodbye.